All right, last proof here. Now, if you look at this picture right away, you're hopefully you're saying, "Oh, you're taking a breath," because look, there's really only two triangles, right? There's three, but there's only two triangles you can prove congruent. So this is not going to be one of those two congruent triangle proofs. But there's a nuance of this proof that I want to make sure I go over. So we're given that E is the midpoint of BD, and we know that angle ABC and angle CDF are congruent, and they're outside the triangle. So that's kind of strange, right? We need to prove that segment BD is perpendicular to segment CE. So let's talk about a couple things. All right, so first, our given. So if E is the midpoint of BD, you should know that these two segments will be congruent. Let me use blue just to be consistent. Now, we know that these two angles are congruent. Now, how's that going to help us? Well, each of those angles forms a linear pair with that angle there and that angle there. So we should know that if two angles, are supplementary to the same angle or congruent angles. So say this was 120 and this was 120. We should know that this is 60 and this is 60, right? So there's an idea there that we'll see in the reasons. So there's a pair of congruent angles, and now where are we going to get the third thing from? Well, we could try to use this middle side, right? But that would be side angle. And remember, side angle is not one of your ways, so we can't do that. So where are we going to get this third thing from? Well, we have to remember the big triangle, right? I will put this in red, right? So in this big triangle, once we prove that these two corner angles are congruent, now we have a big isosceles triangle. And if your corner angles are congruent, then your sides opposite, this side and this side, are congruent. So we don't even need the middle sides. And now this would be side, angle, side. And now how are we going to show that these two lines are perpendicular? I'll change that to green. That would be BD going across and CE coming down. Well, we know that perpendicular means they make right angles, right? So how are we going to show that they're right angles? Well, these two angles are right angles because they're corresponding parts of congruent triangles. So they're going to be congruent by CPCTC. But they also form a linear pair. So they add to 180. Well, two angles that are congruent and add to 180, they have to be right angles. So that's going to be the juxt of that part, right? Or the crux, right? The crux, the juxt, I don't know. So there you go. So we got a lot to do here. So these are not easy proofs. That's okay. You didn't take an easy class. All right, here we go. So let's talk about the midpoint. So if E is the midpoint of BD, we should know that segment BE is congruent to segment DE. That is a midpoint divides a segment into two congruent parts. Awesome. Now let's talk about this angle here. So supplementary angles, right? Because they're a linear pair. Angle ABC, and angle CBE are supplementary because linear pairs are supplementary. Angle being supplementary, angle CDF on the other side and CDE are also supplementary, again, linear pairs. So then because ABC and CDF are congruent, that means that CBE and CDE will also be congruent. CBE, CDE are congruent. And this is the idea of supplements of the same. If two angles are supplements of the same angle or congruent angles, then they are congruent. Awesome. And there we go. And now again, we can't use CE because that would be side angle. So let's use the isosceles triangle theorem and say that segment CB is congruent to segment CD. And that is the isosceles triangle theorem that says in a triangle, sides opposite of congruent angles are congruent. And there is our side, angle, side. These two triangles are congruent right there. Let's call this one CBE. Let's call that one CDE by side, angle, side. Awesome. So now we know that these two angles at E are congruent. So angle EEC is congruent to angle DEC, and that's by CPCTC. We also know that they're a linear pair, so that they're supplementary. Angle BEC and angle DEC are supplementary because linear pairs are supplementary. And now I don't know if I've ever quite done this before on this software, so let me see. I think I can say that one of these is a right angle, right? Because if they're congruent and supplementary, then they're each 90 degrees. So let's focus on BEC. So we're going to say angle BEC is a right angle. BEC. And let's see what the reasons are. So angle, no, angles which are supplementary and congruent are right angles. That's it, right? They're supplementary and congruent, so they're right angles. And if BEC is a right angle, that means that what we want to prove is true. That segment BD and segment CE are perpendicular. And again, if two lines from a linear pair of... Oh, we could have used that reason. Okay, sorry. I use this. If two intersecting lines form a right angle, then they are perpendicular. There you go. How about that? And we did it. And we're done. What? Bada bing, bada boom. Okay? So there you go. So these are not easy. They're not. But you're honors. You're big boys and girls. You can figure it out. And if you can't, ask for help. All right. Best of luck.